Hello everyone, my name is Martin, and I'm the Director of Marketing at Evolvin, and your host for this joint session with Zebia Labs. I'm happy to have on today's session our good friend from Zebia Labs, the VP of Product Management, Andrew Phillips, and Sasha Gillenson, Evolvin's co-founder and CEO. Andrew Phillips is VP of Product Management with Zebia Labs and a cloud, continuous delivery, and automation expert. Hi Andrew, glad to have you here today.
Hi Martin, it's great to be here.
Okay, Sasha Gillenson is Evolvin's founder and CEO. Sasha was the top guru in quality at Mercury and has advised numerous Fortune 500 companies on technology and process optimization. Hello Sasha, how are you doing today?
I'm doing great, Martin. Thank you.
All right, so before we begin, I'd like to welcome all of our attendees and thank you for joining us. This should be exciting. So let's quickly go over the agenda for today's session. First, Andrew will share how deployment automation and XL Deploy help to accelerate releases. Then, Sasha will explain how IT operations analytics complements deployment automation and delivers synergies. We'll follow up with a question and answer session. So, let's get started. I'm going to pass this over to you, Andrew.
Thank you very much, Martin. And of course, let me add my thank you to everybody who's here and who's joined us today, morning, afternoon, or evening. Really looking forward to giving you some insight into how we think, the very exciting opportunities that are out there by combining deployment automation, so CD automation, and IT operations analytics, especially, of course, Evolvin. I'll keep it brief about who we are as a company as well, because we have lots of interesting material I'd like to get through. Basically, we build software to support agile, continuous delivery, and DevOps at scale. And of course, with the ultimate goal of helping you accelerate your business, because that's ultimately the business we're all in today. We have a bunch of tools today, and we'll be focusing on one of them. There's of course plenty more information on our website and other places, but I'll leave you to look at that at your leisure. So for today, my part of what I'd like to discuss here is a bit of the kind of bigger picture. Why are we having this webinar today? I'm sure it's a story that a lot of you are familiar with, but I just want to make sure we recap it briefly. And then I specifically want to talk about some of the requirements related to how we can help in terms of delivering faster, in terms of getting your code out to your customers quicker. And then I'll talk about how XL Deploy can facilitate that and give you some insights on how it can work together with other tooling in order to make the end-to-end process better and more reliable. So I guess the bigger picture, as I said, is a story that most of you have probably heard in one way or another in other presentations, webinars, blog posts, etc. already. Basically, the fact today is that it doesn't matter what industry you're in, whether it's retail, finance, government. To some extent, every business is an IT business. We no longer run software as the sort of back-end stuff to manage our HR systems or something that's kind of a bit boring and it just needs to be taken care of. This is our primary interaction interface with a lot of our consumers. And of course, with that come a lot of expectations. I mean, if we think about how we are used to consuming other things nowadays, whether it's ordering takeout or whatever. So the key challenges we were saying is how do you get the services that you deliver as part of your business out to your users quicker? And whether that's driven by customer expectation, whether that's driven by competitive pressure, if you don't get it out there, there's going to be someone out there that will. This is kind of the overriding imperative that we see, and there's plenty of interesting data in terms of surveys to back this up. I mean, if you look at a number of users who are asked across all kinds of industries, what are the things that you feel most concerned about? And this survey is actually a little bit older even, but the data hasn't changed much. As you can see, making stuff better, meeting customer expectations, or rising in terms of the visibility and the challenge in organizations. And we're of course seeing organizations respond to this. Agile, well, I guess that's almost a traditional thing now. I know it's crossed the 50% mark in terms of being the traditional, the dominant development methodology. We have continuous delivery that I know is on the agenda for a lot of people we speak to today. And I like to call it real agile because really, if all you're doing is putting code into a repository every 2 weeks,
That's all well and good, but it doesn't have much business value in there. And if you actually look at the Agile Manifesto, you will find right there in principle number 1, our highest priority is the continuous delivery of valuable software to customers. So I like to see this as, what we really all should be trying to do if we're going to do Agile properly. And then, of course, you see a lot of companies looking at DevOps as a way of improving the way they run their overall systems, platforms, applications, and encourage collaboration and greater joint understanding to make this easier. So having said that, having said a little bit of the bigger picture around the need to accelerate and some of the initiatives people are taking to do this, well, if we get down to brass tacks, what does it take to get an application or a new feature from your developers where they've written the source code all the way over to where it's running in production? Well, then typically we still have this notion that you have to take it and you move it first into a dev environment, then you have QA, then you do some UAT, and then finally it goes to production. And of course, hopefully the steps that you are taking here are becoming more and more automated. But the fact that I was going to focus on is that you actually have to get this application running in multiple environments. And I mean, this is a relatively short pipeline. And we're seeing people with longer and actually more diverse and sort of challenging branching pipelines for all the different kinds of tests that you run, especially if you're doing a more mobile or connected thing. And long story short, if half of your deployments or more suffer from deployment issues, and I'm very interested to see what kind of data we come up with in the poll, or they just take a long time because you're following manual steps, or you have to wait another day because of the change window, or whatever it happens to be, if this simple fact of getting an environment running and getting an application running in it takes days, hours, weeks, months, I've heard stories that I almost don't believe myself, then you're going to have a really difficult time accelerating the overall delivery of software out to your users. So what we really want to go from is a picture where we have something a little bit like this to something where it's a kind of more streamlined, accelerated process. And of course, deployments aren't the only thing that you will be doing, because in between deploying to the QA environment and the UAT environment, that's when you quote-unquote do the really interesting stuff, namely running your tests and so on. But really we want to make deployment go away as a problem. It should be as painless, if you like, as compilation. You just hit a button, and unless you've got a bug in the code, most of the time it just works. So we really want to make sure that this underlying plumbing is just taken care of, and then we can get it out to production quickly. So in a nutshell, we want deployments to be fast, simple, automated, and of course, well, let's first of all look at Gartner saying the same thing. I mean, so there's plenty of analyst material if you want their perspective on this topic. This has been something they've been saying for a while. But to go back to the point I was making, so we want them to be fast, simple, and automated, but of course also reliable, because it's all very well to have deployments that you can execute quickly because you've thrown together a script or a ball of mud or something along those lines to get your deployments out there. But if the app isn't correctly configured, if you've skipped a couple of steps and you've tried to supplement those by just logging into a machine and quickly making the changes, or you're hoping that the things that were required are still in place from last time and you're not aware that somebody has recycled the server or something along those lines, then this again will turn into another bottleneck and impediment for your overall process. So it's really important that on the one hand you can do the fast, simple, automated bit, but reliability and being able to verify that what you get out there, all the bits that you need are actually going to be put into place, that is a very sort of pure functionality business acceleration perspective. Obviously, I'm sure a lot of our listeners are working in regulated environments where the ability to have a documented audit trail and these kind of things is not just a nice to have, it's actually a sort of critical business requirement. So with the automation and the reliability also comes some of this. But as we know, this is the real world, and especially while you're still in the process of getting your deployments and the rest of your overall pipeline automated, things won't always go perfectly. And even when they are perfect, things still go wrong. And the challenge then, of course, is not so much can we prevent everything possible from happening? I think that's probably impossible, and even if it were possible, the expenditure that it would take is enormous. The other part of the picture is, okay, so we can try and do our best to make things highly reliable, but then what happens when something goes wrong? And there, of course, it starts to become important. If the systems are misbehaving, you want to be in a position where you can discover very quickly what's going on and respond to it appropriately. And if that appropriate response is something like automatically rolling back the deployment, then it's great to have a deployment tool that can do the rollback for you, but you need the detection and the notion that, okay, it's time to do a rollback as well. And so far in terms of, so this of course is based on your ability to monitor and analyze your target environment. But one of the things that is, I think, becoming more and more critical as well is to look at understanding your target environment, not just from the perspective of, oh my goodness, it doesn't work, now we need to figure out what's going on. Even if things go well and the systems behave themselves, if you like, what you really want to find out once you've pushed this new feature live is whether it's actually doing what you expected it to do. I mean, if you think of any other consumer process, we have 4-star ratings, whether it's for restaurant or mobile apps or whatever. It's very important once you've put a new feature live to get a picture of how that changes the overall system landscape. And if it's a feature that you put out there in order to improve performance, then you can, of course, measure the performance of the systems. If it's a feature that is designed to have a more user-facing impact, you need to take some different measurements. But I guess long story short, knowing things about your target environment and about how your applications are running and how they're impacted by changes such as new features is an absolutely critical part of the process, both from the perspective of fast response error remediation, but also from the perspective of discovering whether you're actually building good features in the first place. And that's also very much, indeed, part of the continuous delivery feedback cycle story. You get something into production, you find out how it works, and then you make better choices next time around. So let's go back a little bit and say, first, one of the prerequisites we said that we need in order to make this all possible is to have fast, simple, reliable, automated deployments. And so I'd like to spend a couple of minutes talking about XL Deploy, which is a deployment automation tool, which we build in order to make this possible. So the kind of basic idea behind XL Deploy, roughly speaking, is that it's supposed to get application X running in environment Y. So that could be, my mobile app in the App Store. It could be Pet Portal or Pet Clinic, the famous Pet Clinic, in the development environment or in the QA environment. Whatever it takes to make that particular thing happen, that's the job of what XL Deploy is supposed to do. So of course, typically it hooks up to a whole bunch of other tools. I mean, it's not the kind of standalone thing that you just have there. It's part of the overall integrated landscape that you have. And some questions that commonly come up that I just like to try and address. So the key things from my perspective to know about XL Deploy, also when you're thinking about other potential approaches to this problem, is that it's designed, first of all, to coordinate actions across systems. In many, many cases, the application tier of a lot of our business applications require actions to be carried out across multiple systems in some kind of coordinated sequence, and XL Deploy is designed precisely for that. Obviously, we want to enable environment independence in the sense that you should be building your deliverable once, and then you should be able to transition that from dev to test to QA to production. But as we all know, these environments are always slightly different, and some of the settings have to be slightly different, whether that's usernames or passwords, connection timeouts, whatever. And that, again, is a problem that XL Deploy as an automation tool should just make go away. Obviously, we aim to have a very, very low footprint because you've got enough stuff to worry about already. This should be really lightweight, plug and play. So we've opted from the beginning for an agentless approach, which is pretty interesting. But the other kind of low footprint part is not just when we run, but also how much work you need to put in to actually get your applications out there. So rather than just running arbitrary scripts that you have to write on machines, we provide a whole bunch of, if you like, out-of-the-box Lego building blocks that know how to do many, many, many common actions like run database updates or remove a server from a load balancer pool or create a data source or create a Docker container or whatever. Another thing we're seeing coming up more strongly is the need to go away from big single systems with lots of components to a more microservices type landscape where the challenge lies in the dependencies between the different components. Got some interesting things about that, but I won't talk about that in too much detail in the interest of time. Some of the core concepts you'll see as I explain a bit of XL Deploy, the notion of having a deployment package which defines all the bits that you need to get that application running. So that is code plus configuration related to the application. Now you have target environments, obviously. Those are the endpoints that you will talk to, whether that's databases, app servers, web servers, Docker APIs, whatever, and the environment-specific settings for that specific environment, and the notion of a mapping, which is basically saying, well, these components of my application need to go over to these endpoints in my target environment. And then this mapping through what we call rules allows us to figure out what actually needs to be done. So if you like, one of the most important takeaways from my perspective, XL Deploy is not a workflow or a scripting tool in which you have to tell the system what to do. The system uses rules to figure out what needs to be done, and that makes it highly scalable. We have a sort of internal joke, which is workflow, work slow, and we see that in practice quite a lot. Right, enough slides and bullet points already. Let me give you an idea of what it looks like. So here we actually have kind of the three main components already, but let me focus on them one at a time. The first part is the deployment package, so you can see that on the left-hand side. That will have come from your build system or your continuous integration system. We definitely want that to be a fully automated process. And the relevant part here is it contains not just code like database updates or EAR files or .NET applications or whatever, but also configurations and settings such as data sources, web server configurations, maybe some smoke tests, basically all the components that you need. And the other part of the picture, if you like, those are the target environments. So, of course, depending on your user access rights, you get to choose where you can deploy, and these environments will define what particular endpoints are available. And then in the middle, that's where you do this mapping process, where you say, look, I want these particular components to run on these particular endpoints. And in fact, the example you can see there, well, we're going to map the database components of the package out to the MySQL server. And of course, the system can do all this for you automatically. You don't need to sit in the screen to do this, but it's a nice way of visualizing what's going on. And then the magic, if you like, you click on the next button, and it uses the rules to generate a particular deployment plan for you. And of course, you can inspect it and get a preview and all that good stuff, so lots of detail we could go into. But that's essentially what the system does. It looks at what you have, where you want it to go, and then it does the necessary work. So you can think of it conceptually very much like a PaaS type interface, but then running on your own systems with full control for you. A couple of the points about scalability and how this works across multiple environments I'd like to briefly mention. One of the challenges here, of course, is that the test environment does not look like the QA environment. It doesn't look like the production environment either. So the system needs to be smart enough to take care of the fact that if you take the same application, when you go to the test environment that might be smaller, you have a totally different potentially deployment plan than if you go to the QA or the production environment where it's much larger and you need to take care of things like firewall rules or load balancers or these kind of things. There's lots of additional features. Again, we can very happy to talk about them in a lot more detail. To make it very easy to integrate XL Deploy and especially to scale it out as you grow and you start to hit the inevitable scalability problems. There's dependency resolution, so you can handle dependencies between packages. That's especially important in a microservices type environment. Lots of support for interesting orchestration patterns that people want to apply, such as blue-green deployments, canary deployments, and so on. We can reverse engineer packages from running systems. We can do a bunch of smart things with artifact staging, so you don't have to move lots of files around in a very short deployment window. And in fact, we're about to launch a very cool piece of technology called XL Satellite, which is designed to handle global deployments, even in the face of, let's put it this way, suboptimal network connectivity if you're connecting a data center in, say, Asia Pac to one in EMEA, to one in the US, where there's high latency potentially. Some pretty cool stuff coming, again, as you grow out. And then maybe drilling this back down to the story I was telling a little earlier about being able to integrate your deployment automation with knowledge about what happens when you go live. And I'm sure Sasha will speak a lot more about this. One of the things that we can do here is to say this particular environment, the production environment, is integrated with a tool such as Evolvent, where you can say, well, when a deployment to this environment completes, for instance, if the deployment happens to fail, I want to send a particular event to Evolvent to ask it to carry out an analysis of what's actually going on. But of course, I could do that not just on failure, I could do that on success as well, or indeed, I could do it, as we were saying earlier, not just to try and fix stuff, if you like, but also to try to figure out whether the systems are changing in the way that we anticipate. Has the performance improved because of this refactoring, those kind of questions. But Sasha, as I said, will speak much more about that. So Martin, let me hand it back over to you. And thank you very much, everyone, for listening.
Okay, thank you very much, Andrew. That was really interesting. Just a sec, I'm going to take the controls back. And I'm going to turn it over to Sasha. So, Sasha, take it away.
Thank you, Martin. So, I would like to start with an interesting observation from a very interesting event that happened last year. It was a symposium of CIOs organized by MIT, and the CIOs and CTOs of leading organizations in the world revealed their biggest IT issues. And so here you can see one of the participants, who is the CTO of Fidelity Investments, and that shared his concerns. And this concern was shared actually by every participant of the symposium, was the velocity of the change. And that has two aspects, that concern has two aspects. First of all, how do I get change to the right velocity? And then, as Andrew already said, how do I maintain reliability? How do I maintain my environment in a good state with a high velocity of changes? And why is there a risk? Why? What's the challenge? Once you start to drive intensively these changes. And here is another quote, the kind of interesting, very smart, even cumbersome quote from Donald Rumsfeld. And he mentions that, we can easily deal with the things that we know. Even if we know things that, there are certain unknowns that we know about them, we can deal with them. We can mitigate risks, that we can expect. And however, the most difficult thing is to deal with the unknown unknowns, the things that we even don't suspect that they exist. And when we speak about the world of change, about the IT environment, there is a plenty of the unknowns still there. Well, here are examples, a few examples of these unknowns that our customers report back to us. There are certain things, that happen as the infrastructure, like certain drifts and inconsistencies, that can impede application deployments. There are gaps between pre-production and production environments. You test something in pre-production, production is updated, you do certain decision, and this update in production are not reflected back in pre-production, and so on. When you do the actual, the full stack deployment, there are still certain things that can cause mismatches between the deployment, intended deployment, a planned deployment, and the actual results. Because again, there are so many details when you program the deployment, when you plan the deployment, the mismatches can happen. Plus, on top of that, manual changes can introduce a challenge as well. And when you look into the complex environment that makes physical, virtual, and cloud components, with a full stack of various technologies from application down to infrastructure, it's very difficult to get the whole visibility into everything that happens in this environment, to analyze alerts, issues, performance, availability issues, and get down quickly to the root cause. And just to give you an example, of this unknown, speaking about, actually about the infrastructure side, something like Microsoft Windows operating system has between 1,500 and 2,500 configuration parameters. If you go up the stack, database, something like Oracle can have 3,000 to 4,000 configuration parameters, not counting schemas. You go up to the application server level, and it will be tens of thousands of configuration parameters. So we find sometimes that even vendors are not aware of all the configurations available in the technologies that they are providing. So how to deal with this unknowns? I mean, the data is there. You just need A, to collect it because it's a lot of data, and B, you need to turn it into something actionable. You need to turn it into insights. And so the way to deal with this unknowns hiding in information about the application performance availability, in information about changes in configuration of the environment, information about the machine events happening in the environment, it's IT operation analytics solution. It applies the same way as the business applies analytics to the business data to drive the insights, to get the insights that will drive the business, that will drive reaction optimizing the business. The same way we need to apply IT operation analytics to the data of IT operations to get the full visibility and control of the unknown. And markets and industry experts, thought leaders do share this approach. And for example, Gartner believes that in very near future, in a few years, 25% of Global 2000 organizations will be deploying and relying on IT operational analytics platform. That will be blending the data feeds from a variety of systems, as I mentioned, about application performance and availability, infrastructure performance and availability, changing configurations, and so on, making this one of the key components of the IT management and automation solutions. So how does Evolvent addresses the IT operations analytics questions? How do we provide insights, helping to maintain stability, to improve your processes across the organization? So what we do, we apply analytics to translate very detailed, extremely detailed, and very comprehensive change in configuration information into actionable operational insights. What are the examples of the insights? Is my environment still consistent? Are there any changes that cause an issue reported by, for example, a triggering application performance alert? Is my infrastructure ready for deployment? That's the kind of questions that could be addressed with Evolvent Analytics. The way we work is that we have three main components in our technology. One is actually collection of the information. What we found is that it is very challenging to extract all the thousands of the configuration parameters of the complete bill of material of the environment from every component, starting in application, the top of an application, and down to the infrastructure level. And there's a lot of information, and it's even more difficult to resolve this information to most granular level, to the individual configuration parameters. Now that collection creates a lot of data. And with the agile development, with the deployment driven automatically, the amount of changes only increases. And then there are changes coming from infrastructure, from automated infrastructure, and it's a lot of information. So we analyze this information to identify changes over time or differences across environment with the help of statistical algorithms, of heuristics, of multidimensional analysis, assessing actually a risk score of all the changes and differences to find those critical changes, those critical differences that either caused an issue that you are investigating or could potentially lead to an issue. And then this insight should be obviously communicated to the user. So we have also the visualization layer that allows you to drill down to process this insight and to drill down to the details, as well as the enterprise reports, alerts, and all the other types of the notifications. While getting information about changing configuration is very essential, the most value you get when you blend the various data sources. If you know that there was an APM, application performance management alert, or if you know that there was a log event that generated an error, and you correlate this information with the changes, you correlate symptoms with the changes in environment state, you can find the root cause, or you can predict actually an issue much more accurately. And deployment automation, there's a blend between deployment automation, between release automation, and changing configuration analysis adds another dimension to this insight, to the result that analytics can actually provide. So what is this kind of examples of the results that can be provided by this blending? And it's a variety of areas, starting from accelerating the setup, bringing the very detailed information about the actual environment could be used in the setup phase. And, once you go about automation, you want to ensure that your infrastructure is ready for the automation. It's consistent, it's reliable. And then avoiding deployment issue by verifying, for example, infrastructure readiness, verifying that that no manual changes were introduced through the process, that the automatic process was followed, as well accelerating troubleshooting by analyzing post-release symptoms that we talked about, like performance alerts, as well as identifying proactively high-risk changes that could be a potential source of the issue. This analysis, as Andrew mentioned, it's not necessarily just a troubleshooting analysis. This analysis could be also used for optimization to ensure that expected improvements in behavior of your system are actually in place and recommend optimization. But it gives you the complete, the complete picture from reactive case about there is an issue to proactive one. How can I actually prevent issue and improve my environment. So how does it actually work? Evolving, could be triggered by an event, as Andrew has indicated in Excel deploy, or opposite, can actually generate event back telling about some discovery that happened, some event, some change or difference that we detected that can actually cause an issue and might require remediation. When we drive actually inside, into Evolving to see the data, there are a few components to the analysis. First of all, the actual changes detected by Evolving, so the actual granular changes, the change to particular parameters created by the deployment, the changes to infrastructure created manually or by automatic tools like Chef, Puppet, Salt, and etc. Any changes are actually mapped to the key deployment events, as you can see, at the top of the visualization screen. And then you can focus on the particular events or particular alerts triggered by either side, either by Excel deploy or by Evolving. This color-coded bars actually show you the amount of changes that we detected, also broke down by risk level. Obviously, red is the high-risk changes, yellow medium risk, and green low-risk changes. So essentially, you can see on the timeline, what changes were detected, what actual changes were detected against the deployments that were executed, correlated with information about the APM alerts, log events, or any other, again, information indicating certain symptoms within the system behavior. You can drill down on each of the bars and see the details. Now, the calculation of this risk already embed the information coming from Excel deploy, from APM tools, from log analysis tools, and so on. So here is an example. What happens, when we look into a particular bar. You can see that there are 4 high-risk changes. Why did we decide that these changes, are high risk? Because A, they were unauthorized. They actually were executed outside of Excel deploy activity. They were done also, some of them were done inconsistently, meaning applied only on the subset of the environment against the whole target list. And we see also that our knowledge base indicated that the way the changes were done are actually critical, high-risk updates. It also correlates with the APM alerts. So there were, when the changes were executed, we saw that in proximity, APM alerts were triggered. There were also relevant log errors indicating there is some problem. That are the blended analytic feeds. And so we can drill down and see what are these high-risk changes. First of all, this risk, how do we calculate this risk? It's risk calculated on multiple dimensions. You can see them on the left side, this gauges. Are the changes consistent? How frequently we see the changes? What is the impact as assessed by the knowledge base? Are the changes authorized? What is actually, were there any APM, log, or any other type of events affecting the the risk, indicating that the changes could be triggering some undesired behavior. And these gauges, allow you to control also the weight of different dimensions of the risk as we calculated. And then you can use a change explorer. These bubbles actually represent different groups of the changes, and you can slice and dice the high-risk changes to understand what actually happened. Up to the going at the bottom part of the screen, you can see the detailed information about the change, about the root cause. What actually was a granular individual change in parameter on a file, in registry, in database, and so on. That could be a cause of the alert that you are investigating. So just maybe to mention briefly the background of Evolvent. We work with large to medium organizations. It's a mix of various industries. Our customers deploy Evolvent on thousands to manage thousands of servers across pre-production and production environments. And this approach, this unique approach of actually looking into analyzing the environment through changing configuration data was recognized by a variety of analysts as a high-value approach. And similarly, we get recognition from the industry, being a winner of Red Herring's Top 100 Startups Award, being selected, by various partners we have as a most contributed partner, and represented in various media outlets.
Okay, thanks, Sasha. I'm going to take back the controls now, and let's just go over to our Q&A. Okay, I see that some questions have been coming in as we've been conducting the webinar. So let's open this up. Andrew, you there? Andrew?
Yes, of course. Sorry, on mute. Yeah, I'm here. Just listening on mute.
Okay, great. All right, so we had a question here for you from one of the participants. How do you control SLA targets as solution time for incidents versus continuous delivery? A steady production is always more important as new features.
Well, I mean, I think, put it this way, let me try and, how long do we have is, I think, the ultimate answer. No, so to take the last statement, I think that is a debatable question. To be more precise, I think that is ultimately exactly the kind of trade-off that every organization needs to work out for themselves. Of course, in certain industries where, if you're a microsecond trading algorithm and you make a mistake, you can be bankrupt in 10 minutes. We all know how that happens. But there are plenty of other industries where you can afford to expose, say, a small fraction of your users to an outage if you are able to detect and remedy it quickly. So I think there's a trade-off. Well, something evidently is happening in the background. I think there is a trade-off that needs to be made here about whether you can catch everything up front, or whether you need to do that, or whether you just need to be very quick to, well, isolate the impact of the problem and then get back to a state where your customers are no longer affected. And ultimately, yeah, so the SLAs, yeah, 99, I think that the fundamental challenge is people talk about 5 nines or 8 nines or whatever, without realizing that it's actually a trade-off. 8 nines means certain things, and that's a legitimate trade-off to make in certain circumstances, but it does have a cost in terms of your ability and tolerance for changes. Having said that, I think one of the things that we learned from continuous delivery, and there's plenty of interesting use cases like LMAX, with one of the poster children, that actually you can have better quality and more reliability with continuous delivery than you can with a much more gated approach, because you're making smaller changes. A lot of people come from an environment where a change or release is a big event. You're basically changing hundreds of variables at the same time, and that's because they take so long and they're so complicated. And in that case, of course, it's very difficult to avoid risk. But part of the point of continuous delivery is to allow you to make very small changes where the potential risk and the exposure is also much less. And actually, that seems to work in a way of increasing stability rather than putting it in danger.
Okay, thank you, Andrew. We have a question here for Sasha. How does the evolving analytics approach differ from the traditional change in configuration management practices?
Well, Martin, the traditional change in configuration management practices do have place. However, they need also to adapt to the agile environment. We're not about controlling the process or driving the process. The whole idea of analytics is about looking to the actual results of this process, being it an agile or traditional one, and providing the insights that will help to accelerate the process and to reduce the amount of issues, to optimize it. We look into the actual information, actual data that results from the changes that are actually made, correlate this with other data sources, including traditional change and configuration management tools, as well as, of course, deployment automation tools, and providing insights that can help you to proactively avoid the problems or quickly investigate those problems that resulted from the change.
Okay, thanks. Andrew, if you have a deployment automation setup that works correctly, why would you need analytics to try and verify it? Could you explain what the benefit of having both types of tools are?
Well, I'm curious, maybe Sasha has some comments on this as well. Certainly, I think this gets back to the point I was trying to make earlier, and Sasha also referred to in his presentation. Analytics are not just about breaking stuff and trying to prevent stuff from breaking. So there's a couple of dimensions to this answer. One is that, back to Rumsfeld, the unknown unknowns, it's unless you have a very, very highly controlled environment, and certainly up until the moment where you get there, automation doesn't mean, that somebody can't log into a server and remove the file to which you're trying to write something or whatever. So, there is an element that we need to have here. The extra data always helps in that sense to find out things that happen that you weren't intending to happen. But the other part of it is, and this goes really back to trying to understand not just how do we get features out there better, more efficiently, but how do we get better features out there in the first place? We need to learn about what our systems are doing in production so that we can improve them. And a lot of that, of course, operations has a very, very long history of this, but it tends to be at the very low levels of the stack. We monitor disk space usage and swap file allocation and all kinds of stuff like that. That keeps our systems healthy, but it tells us very little about whether they're really working well from a sort of business perspective. Are the users using the features that we added in the way we want them to use them or whatever? So analytics moving up the chain, and of course APM, and there are many different data sources, so the kind of blending that Sasha was talking about becomes more and more important. This insight into our systems helps us understand whether we're actually building the right features, delivering the right services in the first place. And if this all sounds a little bit pie in the sky and kind of like this is never going to happen, we all have colleagues, most of us in software organizations, who do this today. This is how things like marketing or even HR work in many organizations. And they've become totally data-driven parts of the organization where we measure everything and we do regression analyses and A/B testing, and there's very, very well-defined plans for trying to figure out whether a particular campaign was successful or not. So we're not doing something crazy here. We're just trying to apply some of the same capabilities that other departments have, which are enabled by software, ironically, to the process of delivering software itself. And I think that's just a really important thing to do.
Okay, thanks, Andrew. Now a question for Sasha. Why not apply available BI, business intelligence tools, to IT ops big data?
So what we find is that each type of data actually can provide additional insights if you analyze it using appropriate methods and relevant domain expertise. So BI tools, are good for general analysis of data, but you can't really, you need really to customize them. You really need to understand the IT operations data to provide accurate and relevant insights.
Okay. One more question for Andrew, and I think we're coming up to the end of our time here. So
many tools out there talk about automating deployments, CI tools, provisioning tools, etc. What exactly makes your tool different? Why wouldn't I just keep using the deployment scripts we already have?
How much time do we have? So let me try and be really short on that.
Okay, just a couple of minutes.
No, I mean, we could talk about this. So there are two questions in there that I'd like to try and address very quickly. So why not use the scripts that you have? I guess that's a slightly different question. Well, potentially there's no reason not to. If everything works, then it's unlikely you're going to be able to identify a strong business case for changing. But the reality of writing scripts is they're never done, especially in this space, because you always have to add another new thing or support a different technology or add support for blue-green deployments or whatever. And then secondly, of course, you get the classic build versus buy problem. A lot of the deployment scripting that exists out there was written by someone who's no longer with the organization, and it's full of the classic look, don't touch type comments, which for really kind of essential business process tooling is a bit dangerous, so that's a bit of a business risk. But what we find is that the incentive to change obviously comes generally with new technology, increase in features and requirements, those kind of things. Regarding the other tools, well, that is, of course, a good point, and it depends a little bit what you mean by deployment. In an ideal world, you can architect all your applications so that deployment just goes away as a problem. But we don't live in an ideal world, and a large number of the applications we see require exactly the kind of features that I was talking about earlier, and that are relatively difficult to do in a kind of feasible way with some of the tools that have been mentioned. Cross-machine orchestration, handling dependencies, handling environment-specific configurations, just basic insight and reporting, answering simple questions like which version of an app is running in which environment, is it ready to go to the next environment. Those kind of things require a domain model that is associated with deployments and requires some sort of specialist orchestration functionality that a lot of the other tools don't have, or that you end up basically building yourself. I mean, Sasha said much the same thing about Evolve and business intelligence. Of course, to some extent, it's a generic problem, but really getting it right requires a lot of domain-specific features, code, understanding that if they're not in the tools that you have, you're going to have to build yourself, or you're going to have to avoid, and that gets very hard in the deployment space.
Okay, thanks, Andrew. Now, one last question for Sasha. Can you talk about scalability? How large and complex have you successfully tested? And the number of platforms involved, number of configuration items?
So it's always a question when you think about analytics. The enterprise environments could be quite big. Right now, we go to 25,000 servers, a couple of hundred of millions of CIs, a frequency of 2 to 3 million changes per day, and that's what we experience with the customer, with the actual customer environments.
Okay. Well, thank you very much. That's all the questions we're going to be able to address today. We'll be able to get back to the other questions offline. So I'd like to thank you all for taking the time to join us on this session. I personally found this all very interesting, and feel free to drop us a line. I'll just put the information up. Here we are. Drop us a line with questions or feedback, or you can contact either of us to schedule demos or get involved in. You can get involved in the Evolve trial, and you can also visit Zebia Labs, where you can download for free the Excel release and Excel deploy. And stay up to date on the latest about IT operations analytics over at the ITOA landscape, and you can follow the Twitter channel as well. So, on behalf of all of us, I want to thank you all for taking the time for joining us today. Thanks again, Andrew and Sasha.
Thank you, Martin.
Thanks, Martin.
Okay. Okay, thanks. Looking forward to hearing from you all.